20-1s. Last little lesson in radicals. Everybody's favorites. Let's do some word problems. Every time the word problems and that expression comes up, I get scowls from students. Oh, I hate word problems. Well, the good thing is you're not alone. The vast majority of students hate word problems. With this, though, today, we've solved radical equations. Hopefully there wasn't too much difficulty with that. Now it's just a matter of trying to create the problems themselves. And again, with word problems, I don't think the difficulty is the solving. We're solving radical equations. It's getting the radical equation from the word problem. Well, as the math becomes more complicated, the word problems sometimes get less complicated. Now, if you take a look in the booklet on page 16, here it talks about how the radius of a sphere is related to the surface area of the sphere. Well, the radius of a sphere, of any ball, round, globe object, is equal to 1/2 the square root, so half the square root of the surface area divided by pi. It's a formula, it gets given to you. So sometimes the word problems aren't that bad because they're given to you and then you just have to substitute in and solve. Now, we're going to look at the second one in a minute that's a little bit more involved, but if the word problem gives you the information, it's simply a matter of identifying what you're trying to solve for and what's given. So question A tells us we know the surface area is 172 centimeters squared for a baseball. We want to know what the radius is. Well, your equation's given to you, and what's nice in this first one, we want to know the radius. Well, the radius is what the equation is designed for. We don't even have to do any algebra. Half the square root of the surface area divided by pi. So in that, substitution is just going to give you your answer once you do the work. How much you plug into your calculator at a time is totally up to you. I've talked about the fact that I like to break it into parts. So I would do my square root calculation first, and then I would multiply by 1/2. I don't want to plug everything in at once. I'll make too many errors. You've seen it. I like to break it into steps. So we want the square root of 172 divided by pi. So I'm going to go 172 divided by and come up with the pi symbol to be more specific. There's what I want. And I want the square root of that so I can grab it. And I like to break it into parts. So there's my 172 divided by pi, square root it, and I then have to multiply that by 1/2. Well, the nice thing about 1/2 is it's a terminating decimal, so I'm just going to multiply my answer by 1/2 or 0.5, and we get, based on what the question asks for, rounded to the nearest tenth of a centimeter, 3.699. 9 tells us to round up, so we get a radius of 3 7/10 centimeters. Nice, straightforward word problem with the equation given, and then we can plug it in. Question B, a little bit more involved, still working with the same equation, but this time the radius is given to us. So now when we substitute in, we get the radius of 3 3/10, and that's equal to 1/2 square root. We don't have a this time, and it's still divided by pi. So now we need to break it into steps. Well, how do we, radical equations, solve the radical equation? First thing is we want to isolate the radical. So I need to divide by 1/2, which will give me 3 3/10 divided by 1/2. You're not splitting it in half. That's divided by 2. We're actually doubling it. We get 6 6/10 equal to root a over pi. Well, here's what we spent time with solving radicals. At this point, we want to get rid of the radical sign. We square it. Because a radical times itself leaves us with just the radicand. So if I do root a over pi square rooted and I square that, I'm left with a over pi, but I have to make sure I square the other side. And my 6 and 6/10, when I square that, is 43 and 56/100. At that point, to get a by itself, we're dividing by pi. And if I'm dividing by pi, I can multiply by pi. So I multiply by pi on this side, and the area or surface area of that tennis ball, rounded to the nearest square centimeter, so whole centimeter, is 137 centimeters. So again, some word problems in this, because of the complexity, it can be hard to create them. Sometimes they're just given. Know what you have, know what to substitute in for, know how to solve. So the next question. Read it, pause, and then solve it and get some work done. So when you get a question you have to create, it starts to get a little bit big and ugly, and you have to read careful. Get an idea for what the question's asking and then go from there. So this one says backpackers were on a hike to a backcountry campground. From the car, they hiked to a river. So I break it into pieces. So here's the car. There's the car. Well, there's no exhaust because they're now parked. From the car, they hiked to a river a certain distance. So they hiked to the river. Well, now we have a river. So there's the river. And they're now going to hike along the river. But what do we know? They hiked to the river a distance described as square root of a number doubled and increased by 6. So the distance to the river was described as the square root of a number doubled, so there's double a number, n, and increased by 6. So there's the distance they walked to the river. Then what did they do? They then followed the river for a distance. Well, at that point, let's assume they're now in their tent. They have their little fire pits made of rocks to be safe, and they can now roast their marshmallows on their fire. But the distance they traveled along the river is described as triple the same number, just 3n. And we know the total trip was 19 kilometers. So there's not a ton going on in the question, but you have to read careful. So what do we know? The total trip of 19 kilometers was the 2n plus 6 rooted length and that 3n length. There's your equation. It's wordy when it's given in a word problem form, but you just have to read careful and break it down. So take a second to solve it if you haven't. Otherwise, here we go. What are we going to do to solve? We're going to subtract 3n so we can isolate our radical. So we have 19 minus 3n is equal to the root of 2n plus 6. Want to get rid of the root sign, so I square that side, and I'm left with 2n plus 6. And I then have to square the other side, some big numbers, but the calculations aren't difficult. The process, use your calculator to support you. When you do FOIL there, I'm going to do FOIL and rearrange it at the same time. We end up with 9n squared minus 116n plus 361 equal to the 2n plus 6. So that was plus a 361, and it was equal to the 2n plus 6. So equation, check. Isolate the radical, check. Square both sides, check. And now we solve. From the solving radicals, how do we solve at this point? Well, the radical's gone. We see we have an n squared, so we have to solve the quadratic. Solve a quadratic, everything goes to one side, so I'm going to move the 2n and the 6 over, and I get left with 9n squared minus 100. Oh, my bad. I apologize. I jumped ahead in a step, which might have confused some of you. I do apologize. We have the 2n plus 6. When we do the FOIL, we end up with 9n squared. But instead of the negative 116, I apologize, I jumped a step there. It's negative 114n, and that's plus 361. Sorry about that. Little backtrack. When I move the 10 or the 2n over, I have 9n squared, negative 14. The 2n becomes a negative 2n. There's your negative 116n. When the 6 comes over, I have to subtract 6. So that leaves me with a positive 355, and that equals 0. Now we have a quadratic equation equal to 0 we can solve. I'll be honest with you, big numbers like that, that's going to be a lot of work if I try to factor it, I think. So I will go to the quadratic equation. What is x equal to? Negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So the quadratic equation, quadratic formula is a nice way to solve it because of the size of the numbers. You have a calculator to support you. You could try factoring. I'm just going to deviate to the quadratic formula. At that point, do the work, get your radical value. We end up with 116 plus or minus the square root of 676 over 18, which tells us what's nice. The square root of 676 is actually nice because it is a whole value, which is 26. So we can go, x is going to be 116 plus 26 divided by 18, or x is going to be 116 minus 26 divided by 18. The first time, our x works out to be 7.89. The second time, our x works out to be 5. So 2 possible solutions. But we have to be careful. We always have to check for extraneous roots, no matter what, anytime we solve a radical equation. If I do a verification of the first one, we have root 2 times 7.89 plus 6 plus 3 times 7.89, and I want that to equal 19. Well, when I do the calculation using x equal to 7.89, we get 28.3 equal to 19. That's not true. So 7.89 is an extraneous answer. If I verify the second solution of 5, we root 2 times 5 plus 6 plus 3 times 5 equal to 19. When we do that, we get 19 equal to 19. So x equals 5 is the correct solution. Lots of work, but manageable if you understand your processes. The setting up is the tricky part. Last thing, have we answered the question? How far was the stretch to get to the river? That's what it's asking. So I used x in this. Really what we were solving for was n. I apologize for changing my variable, but we're saying that n is 5. So to the river, our final answer to the river was the root 2 times 5, because that's our solution, plus 6. That's how far it is to the river. When we do that, 10 plus 6 is 16, rooted 4 kilometers to the river. So, word problems. Everybody loves them. At this point, your assignment, please, for today is page 300 from the textbook, questions 12 to 18. Some are nice and straightforward. Some require a little bit of creating the equation, but they're manageable. Give it a try. You have some review work, review assignment on the classroom as well right now. So lots to keep you occupied. Assessments coming up. Have a great day.